I started with 2,535 modeled green hydrogen candidate sites, and when I ran them through H2 Hub's default screening rules, only 532 passed. But before we go any further, there is an important clarification. These are not 2,535 named real-world hydrogen projects. They are synthetic anonymized candidate sites designed to test and demonstrate a structured screening methodology. So the real question is not, which site should immediately be built? The real question is, which candidates look promising enough to justify deeper analysis? What actually makes a hydrogen site good? The obvious answer might be renewable energy, strong solar, strong wind, maybe both. But H2 Hub's current screening engine looks at more than one resource variable. It considers hydrogen production, solar resource, wind resource, electrolyzer efficiency, overall system efficiency, and desalination energy load. The idea is simple. A site should not rank highly just because one variable looks attractive. It should perform reasonably well across a combination of factors. This is a screening exercise. That distinction matters. Screening is not detailed engineering. It is not permitting analysis. It is not financing due diligence. And it is not a final investment decision. The purpose of screening is to reduce a very large number of possibilities into a more manageable group of candidates. Think of it as the first filter in project development. Before spending significant time and money studying a site, you first ask, does this candidate deserve a closer look? The current H2 Hub dataset contains 2,535 modeled candidate sites. Each one is synthetic and anonymized, but each candidate is scored independently. The underlying data includes variables such as latitude and longitude, solar irradiance, wind speed, electrolyzer efficiency, modeled hydrogen production, system efficiency, and desalination energy load. This means the screening engine is not simply producing one general score. Each candidate goes through the methodology separately. Every candidate faces the same rules, the same eligibility gates, the same normalization process, the same default weights. That consistency is one of the most useful parts of the methodology. Instead of manually deciding that one site looks better than another, the system applies the same framework across the loaded dataset. And because the logic is visible, the user can understand why one candidate outranks another. The first stage is eligibility. Under the default configuration, a candidate must meet minimum thresholds. Solar resource must reach at least 5.8 kilowatt hours per square meter per day. Wind speed must reach at least 5.8 meters per second. Electrolyzer efficiency must reach at least 74%. Overall system efficiency must reach at least 77%. And desalination energy load must remain at or below 14 kilowatts. Fail one of these gates, and the site is excluded from the ranking. This creates the biggest drop in the entire process. We started with 2,535 modeled candidates. Only 532 passed the default screening gates. That means the majority were removed before ranking even became the main issue, and I want to emphasize the word default. If the user changes the thresholds, the number of surviving sites changes too. That is not a weakness. It is actually part of the purpose of the tool. Different projects can have different minimum requirements. Passing the screening gates does not mean a candidate wins. It only means the candidate remains eligible. Now we still have 532 sites, so we need another level of evaluation. This is where H2 Hub assigns normalized scores, applies the selected weights, calculates the total, and ranks the surviving candidates. This is also where user priorities begin to influence the result. The default ranking uses 6 weighted factors. Hydrogen production receives 25%, solar receives 20%, system efficiency receives 20%, electrolyzer efficiency receives 15%, wind receives 10%, and lower desalination energy load receives 10%. Together, those weights total 100%. This is important because the ranking reflects a defined set of priorities. It is not an absolute truth about the site. Hydrogen production carries the highest individual weight at 25%. That gives it substantial influence over the total screening score. But there is another important clarification. The production value at this stage belongs to the screening dataset. It is not the production output of the 100 megawatt project we will configure later. Those are different calculations. The screening stage helps compare candidates. The later project stage calculates production based on the actual project configuration. Solar receives 20% of the total score. That is significant, but it also means that being number one in solar does not guarantee being number one overall. A candidate can have exceptional solar resource, but still lose ground because of weaker system efficiency, lower modeled production, poor wind performance, or a higher desalination burden. This is one of the central lessons of the screening process. A single strong variable does not automatically create the strongest overall candidate. Wind contributes another 10%. Again, H2 Hub is not saying that wind is more or less important in every real hydrogen project. This is simply the current default weighting. The value is that wind sits alongside solar rather than being ignored completely. This creates a broader resource picture and allows the user to increase or decrease wind's influence if the project priorities change. Efficiency is extremely important in the default ranking. System efficiency receives 20%. Electrolyzer efficiency receives another 15%. Combined, that means efficiency-related variables represent 35% of the overall score. That is more than solar, and more than hydrogen production alone. So the methodology is not simply asking where is renewable energy strongest, it is also asking how effectively does the modeled system convert those inputs into useful hydrogen output. This slide needs an important distinction. H2 Hub currently screens desalination energy load. It does not verify actual water availability. It does not verify water rights. It does not confirm groundwater supply or abstraction permits. And it does not prove that a hydrogen project has secured a water source. What it does is use desalination energy demand as one of the screening variables. So this should be understood as an energy load proxy, not a complete water resource assessment. The screening variables use completely different units. Solar is measured one way, wind another. Efficiency is measured as a percentage. Hydrogen production is measured in kilograms per day. Desalination burden is measured in kilowatts. So before combining them, H2 Hub normalizes the values onto a comparable scale from 0 to 100. Then the selected weights are applied. This allows very different technical measurements to contribute to one combined ranking. After eligibility, normalization, and weighting, H2 Hub calculates the total screening score. Then it sorts the candidates from highest to lowest. This creates the ranking. At first, that might sound like the end of the analysis. Find number one, take the winner, move on. But this is actually where the most interesting part begins, because the ranking changes when we change what matters. Suppose I decide that the default weights do not match my project. Maybe solar matters more, maybe hydrogen production matters less, maybe system efficiency matters significantly more. H2 Hub allows those priorities to change. For example, I could reduce production from 25% and increase system efficiency, or increase the importance of solar. And when those weights change, the total scores are recalculated. This is the moment I would show live on screen. Move the weights, then watch the leaderboard reorder. A site that was number one can lose its position. Another site can move upward. That tells us something extremely important. The best candidate is partly a function of the priorities built into the scoring methodology. The ranking is not independent of the question we are asking. And that leads to the real insight. There is no completely context-free number one site. A solar-focused project may prefer one candidate. A project focused on maximum hydrogen output may prefer another. A project prioritizing system efficiency may produce a different ranking again. So the real value is not simply seeing who ranks first. The value is understanding why the ranking changes. But this is where screening ends. A high screening score does not mean a project is ready for investment. The screening engine does not currently rank sites using electricity price. It does not rank using electrolyzer capex. It does not rank using LCOH. It does not include full grid access analysis, port access, industrial demand, permitting, or financing. So we have to be disciplined. Screening tells us which candidates deserve more attention. It does not tell us which project should be financed. Now we choose one candidate. H2 Hub can carry that site from the screener into project design. The handoff retains the screening context, including the coordinates, rank, selected site variables, weights, thresholds, calculation version, timestamp, and dataset provenance. That is useful because the user does not have to rebuild the project from zero. The site enters the next stage with its screening history attached. Now we configure a project. For this demonstration, the electrolyzer capacity is 100 megawatts, and this is where we have to separate screening from project economics very clearly. We are no longer analyzing all 2,535 sites. We are now analyzing one selected project. The economics engine calculates project hydrogen production using the project capacity, capacity factor, and efficiency assumptions, so this is a new level of analysis. Once we enter economics, the questions change. Now we care about electricity price, capacity factor, electrolyzer capex, balance of plant capex, fixed operating cost, stack life, offtake price, delivery assumptions, distance to demand, incentives. These variables feed the project economics, including LCOH and delivered cost. This is the stage where we begin asking, does this project still make sense under the assumptions we are using? Then we push the project further. H2 Hub currently includes 4 named stress tests. First, utilization miss. What happens if the capacity factor falls? Second, power price shock. What happens when electricity becomes more expensive? Third, incentive removal. What happens if financial support disappears? And fourth, offtake delay. What happens when the project produces hydrogen, but the expected commercial timeline slips? This is where the model starts testing resilience rather than simply reporting a base case result. So what did ranking 2,535 model candidate sites actually teach us? First, only 532 passed the default screening gates. Second, the ranking is influenced by the priorities we choose. Change the weights and the leaderboard can move. And third, screening and economics answer completely different questions. Screening asks, what looks promising? Economics asks, does the project survive? That is why the best way to describe the H2 Hub workflow is screening tells you where to look. Economics tells you whether to keep looking. And if you want to explore the screening workflow, change the assumptions, and test your own scenarios, you can explore H2 Hub using the link below.